Hello students, welcome back to all. In today's class, we are going to explain about the classification of elements, the periodic table, one of the most important topic. So now, let us see what is the necessity of classifying elements and how the periodic table will form. Let us discuss all the topics. So before going to see that, see if a medical shop contains a vast number of medicines, right? So, for example, the shopkeeper finds difficult or impossible to remind all the names of medicines. So, when you go to a medical shop and ask the shopkeeper for a particular medicine, he hands over it to you without any difficulty. How it is possible? It's not only in case of medical shop. For example, if you go to the supermarket, so when you step inside, you see a particular arrangement of goods inside it, which means from the two examples we have to understand that for any system involving several things, a particular arrangement is required. So it's very important, not only in case of medicals or whatever it may be. If there are so many several things are there in a system, particular arrangement is required. It is very essential. So to find out the particular thing. So in the same way, the classification of elements is also necessary. Why? Because even in chemistry from earliest times, so scientists have been trying to classify the available elements on the basis of their property, because in the periodic table now at present it is containing up to 115 elements, right? So it is not easy to find a different particular element. So it is essential to arrange the elements in a particular order. It is very essential. So that is why classification of elements is very essential thing. So at first, I think around 1661 time, the first scientist called Robert Boyle, he defined that what is an element. So element means any substance that cannot be decomposed into a further simple substance by a physical or chemical change, which means element means we cannot decompose it into a further simple substance. This is the simplest form. So at his time, at 1661 around, he found 13 elements. At the end of the 20th century, the scientist called Lavoisier, another 11 elements were discovered. See, at the time of 1865, about 63 elements were discovered. And at the time of 1940, the total number of 91 plus 17 elements were discovered. Now at present, there are total number of 115 elements are there. So here 91 plus 17 means 91 are natural elements and the 17 elements are from synthetically obtained, which means at that time the scientists tried to find the synthetic elements also. So in olden days, mainly there is only one type of classification is there. Elements are broadly classified into two types. What are the two types? Metals and non-metals. See, it is a classification, okay, but this classification are also having so many limitations. So all the properties or all the elements not obeying the metals and non-metals. So there was a need of classifying them in other ways. So many chemists are trying to find out or classifying the elements basing on their physical and chemical properties. Physical and chemical properties. So in this way, the scientist called Darwinier. So it is very important. This is he is the first scientist at the time of 1829. He arranged elements in the form of triads. So this is the first classification of elements. So what is the first classification of elements means? Darwinier's triad. In 1829, he classified the elements in the form of triads. Let us see more points about it. So what is Darwinier's law of triad? What is the meaning of triad here? So he is a German chemist. He noted that there was group of elements with 3 elements known as triad. So triad means it is containing 3 elements. And moreover, the 3 elements having the similar chemical properties. It is very important. So the 3 elements, the group of 3 elements is called triad, and those 3 elements having the similar chemical properties. It is very important. So he tried to give a relationship between the properties of elements and their atomic weights. So the Darwinier tried to give the relationship between the properties of elements and their atomic weights. So it is very important point. Who is the first scientist classifying the elements basing on their atomic weight? So the question will be like this. So the answer is Darwinier triad, law of triad. So he started that the elements with similar properties are taken 3 at a time and arranged their ascending order of their atomic weight. So here one more point is there. For example, A, B, C. This is called a triad. The 3 elements having similar chemical properties, and he arranged the 3 elements basing on their ascending order of their atomic weight. So here he told that the atomic weight of the middle element is equal to the average atomic weight of the first and last number. So this statement is called Darwinier's law of triad. So what is Darwinier's law of triad? Law of triad means the average atomic weight of the first and third elements is equal to the atomic weight of the middle element. So this law is called law of triad. So what is law of triad means? This one. Let us see some examples. So here, see the first example. So these are the examples for Darwinier's triads. These 3 are 3 triads. So in the first case, lithium, sodium, potassium. So the average weight of the lithium and potassium, 7 plus 39 by 2 is equals to 23. So it is equals to the atomic weight of the middle number. In the same way, in the second case, the average weight of calcium and barium is equal to the strontium. But here, the weight is equals to 88.5, which means it is approximately equal, not exact. In this third case, chlorine, bromine, iodine. So the bromine weight is 80 and chlorine and iodine average weight is 81.25. So here also it is also approximately equal. These 3 are the examples for Darwinier's triad. Let us see some more examples. So here sulfur, selenium, tellurium. So here the weight of selenium is equal to the average weight around 78.5. It is also approximate. So manganese, chromium, ferrum. Here the average weight is 55.5. So these are the examples for triad. So how the question will come from the triads? So which of the following, question will be like this in your exams, board exams or competitive exams, whatever it may be. Which of the following is not a Darwinier triad? So option A, lithium, sodium, potassium. Option B, calcium, strontium, barium. and option C, fluorine, chlorine, bromine, and option D, chlorine, bromine, iodine. So here the correct answer is C, because fluorine, chlorine, bromine is not a Dobereiner triad. So these above three are only triads. So like this the question will become. See, this lie is somewhat acceptable, but it is having some limitations. What are the limitations? Let us see. So limitations. The first point. See here, all the known elements at that time could not be arranged in the form of triads, which means only some few elements are only arranged in the form of triad. So this is the first limitation. And the second limitation is in case of fluorine, chlorine, bromine. So the atomic weight of chlorine is not equal to the arithmetic mean of fluorine and bromine, which means this lie is failed for very low masses of or very high mass elements. It is only acceptable for only some elements. So that is why this is the second limitations. And the third limitation is that as the techniques improved for measuring atomic masses accurately, this law was unable to remain strictly valid. For example, in case of calcium, strontium, and barium. So here the calcium weight is 40.0 and strontium is 87.5 around and barium is 137.0. So here the arithmetic mean of these two is equal to 88.85 here. In so many triads, the value is approximately equal. But as the techniques are improving, the atomic masses are measuring accurately, not approximately. So that is why it is also one of the limitations. So this is what about the Dobereiner's law of triad. So to overcome the limitations of this Dobereiner's triad law, one more classification came forward. Let us see. The Newland's law of octaves. So the Newland is a British chemist at 1865 around. He found that when elements were arranged in the ascending order of their atomic weight. So here it is also basing on their atomic weight only. So it is very important point. Classification is first introduced basing on their atomic weight means that is Dobereiner's law of triad. In second case also, the Newland also, he found that while arranged the elements in ascending order of their atomic weight to fall into 7 groups, each group containing elements with similar chemical properties. So based on the observations, he proposed that Newland's law of octave. So let us see what is the law of octave. So the law of octave means, he states that, see, when the elements are arranged in the ascending order of their atomic weight, they fall into the pattern which their properties repeat at regular intervals. For example, just a minute. See here, this is Newland's law of octave, which means what happening here? See, he arranged the elements in the ascending order of their atomic weight. So here hydrogen, lithium, fluorine, sodium, chlorine, potassium, like this all the elements will be arranged in this way. He told that every 8 elements starting from a given element resembles in its properties to that of the starting element. For example, this is the hydrogen. This is the first element. So it is having similar properties that of the fluorine because it is 8 elements. So 1, 2, 3, 4, 5, 6, 7, 8. So that is why he gave the name law of octave. Octave means here he take 8 elements. In the case of triad, only here 3 elements will be there in triad. But in case of law of octave, Newland's law of octave means here 8 elements. 8 elements are taking as a group. So, for example, here the hydrogen having similar properties to that of fluorine, and lithium having similar properties to that of sodium, like this. And here the fluorine having similar properties to that of chlorine. So 1, 2, 3, 4, 5, 6, 7, 8, like this. Elements with similar chemical properties are to be present along a horizontal row. So here hydrogen, fluorine, chlorine, cobalt or nickel, bromine. So all the elements having similar properties. Here one more point. He told that the Newland was the first to assign atomic number to the elements, which means he gave atomic numbers to the elements. So hydrogen atomic number is 1, 2, 3, 4, 5, 6, 7 and 8, 9, 10, like this. So the question will be there. Who is the first scientist to give or assign atomic numbers to the elements? So no doubtedly Newlands. He proposed his classification based on their atomic weights only. There is no confusion. See here, he proposed his theory basing on their atomic weights only. But he assigned atomic numbers to the elements in the first time. But unfortunately, his work was neither accepted by his seniors and nor by the Journal of the Chemical Society, which is rejected because it is having some limitations also. See the Newland's table of elements, if you start with hydrogen and move down, then start at the top of the 8th element is fluorine and next 8th element is chlorine, like this. So here he told that the properties of hydrogen, fluorine, chlorine, cobalt or nickel, all the elements are having similar properties. Similarly, in the case of lithium, sodium, potassium, all the elements are having similar properties. So here there are some limitations are there. What are the limitations? See, in case of, so here cobalt and nickel, some slots, certain elements, in some slot there are 2 elements are there. 2 elements are fitted into the same slot. See, these 2 elements are fitted in the same slot. So this is one limitation. And certain elements totally dissimilar in their properties were fitted into the same group. For example, here cobalt, nickel, palladium and platinum and iridium. So these elements are fitted in the same group with fluorine, chlorine, bromine. What are these? Halogens. So here these halogens are not having similar properties with the cobalt or nickel, palladium, platinum and iridium. But he arranged all the elements in the same group. So this is also one limitation. So here this is, he told that the horizontal line is called row and the vertical line is called group. So he arranged these elements are having similar properties in a first row, but all the elements not having similar properties because fluorine, chlorine, bromine, all these are halogens. Halogens having not dissimilar properties with the other elements. It was found that law of octave holds good only for the elements up to calcium. See here, it is acceptable up to calcium metal only. The law was not valid for the elements that had atomic masses higher than calcium. It is also one limitation. And it is, he told that in the periodic table up to 56 elements only, he arranged the elements up to 56 only. and did not leave any gap for the new elements. So elements that were discovered later could not be fitted into the Newlands table in accordance with their properties. So this is also one of the limitation. So basing on their limitations, this lie is also not acceptable. And he told that the first element having similar properties with the eighth element means he compared like sari gama pa. Padani. So 7 musical notes in a scale. Like the 7 musical notes in a scale, first sa, re, ga, ma, pa, da, ni. Then after again sa will come. In the same way, he told that the 7 elements, the first elements having similar properties with the 8th element, and the 8th element having similar property with the 15th element. Like this he compared. It is one of the comparison. But of course he tried, but due to having some limitations, this law is also not accepted. So now Mendeleev's periodic table. Mendeleev's periodic table is, see, the first in the classification of elements, the first Dabranier is there. So he classified the elements in the form of triads basing on the atomic weight. But it is having some limitation. To overcome the limitation, another scientist came forward and he proposed the theory law of octave, Newlands law of octave. So he proposed the octaves. Octave means having 8 elements similar chemical and physical properties. But this law of octave also having some limitations. So to overcome the limitation, the scientist called Mendeleev proposed a theory or give a classification of the periodic table is called Mendeleev's periodic table. So here he also arranged the elements in a systematic order of increasing order of their atomic weights. See, it is also very important point. The 3 classifications, whether the triads, law of triad, or the law of octave, or the Mendeleev's periodic table, all the 3 classifications are based on the atomic weights only. It is very important. See, the scientist, the Newland is first assigned the atomic number to the elements. At that time, the atomic number is not given to the elements, but he assigned the atomic number to the elements in the Newland's time. He is the first one. But all the classifications are based on the atomic weights only, up to Mendeleev's periodic table. Okay? And he arranged the elements in the form of a table. He arranged some rows and some columns in this way. So the chart into 8 vertical columns. See, it is very important. 8 vertical columns known as groups. And here each group is again divided into 2 types, A and B. These are subgroups. And also each column containing elements are having similar physical and chemical properties. And also he told that there are some horizontal lines also there in the table. Those horizontal lines are called periods. Is it okay? So there are 8 groups and 7 periods in the Mendeleev's periodic table. See, in the case of triad, only 3 elements will be there. But in Newland's law of octave, there are total number of 56 elements are arranged in the table. But now, in the Mendeleev's periodic table, the elements are arranged in the form of a table, and he gave the vertical columns are called groups and 7 horizontal lines are there. Those are called periods. And the group containing 2 subgroups A and B. Let us explain just a minute. So this is the Mendeleev's periodic table. So here these are groups 1, 2, 3, 4, 5, 6, 7, and 8, total 8 groups, and 1, 2, 3, 4, 5, 6, 7, total 7 periods. So here again there are subgroups A and B. So in the first group, see here the elements in the first column, for example, here R2O, RO, R2O3, RO2, R2O5, which means here in the first group it is containing hydrogen, lithium, sodium, potassium, calcium. So all the elements, whatever it may be, when they react with oxygen, it gives, the lithium react with oxygen gives Li2O, lithium oxide, Na2O, K2O respectively. So the generalized formula is given. R2O means when the group 1 elements react with oxygen, it gives the formula respectively. So in the same way, the elements in the second column react with oxygen, it gives beryllium react with oxygen gives beryllium oxide, and magnesium react with oxygen gives magnesium oxide, or calcium gives calcium oxide. So that is why here the formula is RO. Like that, here he is giving the generalized formula when react with oxygen. So here before to explain this periodic table, we have to know one point. What is the periodic law? So the periodic law means based on Mindless's observations regarding the properties of elements in the periodic table, a law known as the periodic law of the properties of the elements was proposed as follows. So the law states that the physical and chemical properties of the elements are the periodic functions of their atomic weight. So which means he also arranged the elements in the based on their atomic weights. So this is the law of the periodic law. Is it okay? So here in the first group, let us come to the first group. So there are total number of 8 vertical columns are there. So group 1, 2, 3, 4, 5, 6, 7 and 8. And those group numbers are represented with the Roman numericals. And here subgroups A and B, in each group containing some subgroups A and B. In the first subgroup, see here lithium, potassium, rubidium, cesium. This is A. And hydrogen, sodium, copper, silver. This is B group, like this. So in the each group A and B, A and B, A and B, like this. In each group there are 2 subgroups are there. While coming to the periods, the horizontal rows in the Mindless's periodic table are called periods. There are 7 periods, and those periods are giving the numbers from 1 to 7. And here we have to know some points. The Mindless, see here. So here the Mindless is predicting the properties of some missing elements, which means he thought that based on the arrangement of the elements in the table, he predicted some elements were missing in the table, and he left some, see here some gap is there. Is it okay? Here some slots also given, some gaps. He thought that some elements were missing, and he left blank space for the appropriate places in the periodic table. So Mindless believed that some new elements would be discovered definitely, and the properties of these new additional elements in advance purely depending on this table only. So he predicted the properties were almost the same as the observed properties of the elements, and he left some blanks here. For example, he told that Eka boron. Eka boron means scandium. Eka aluminium means gallium. and aqueous silicon means germanium. So like this, he predicted some places or some slots for the discovered elements. So this is one of the important point. And now, fourth point. See, the correction of atomic weight. So generally, at the time of Mendeleev, the beryllium's atomic weight is given 13.5. So generally, how the atomic weight will come? Atomic weight is equals to equivalent weight into valency. So the equivalent weight of beryllium is found approximately 4.5 and the valency is 3. So total weight is equals to 13.5. But with this atomic weight, it has to be placed in the wrong table, wrong group in the periodic table. He said that its valency should be 2, which means the beryllium's valency should be 2 only. Then the atomic weight becomes 9 because 4.5 into 2, that is equals to 9. So the atomic weight of beryllium is 9, which means he corrected the atomic weight of beryllium. Up to Mendeleev, the atomic weight of beryllium is thought to be 13.5. But it is wrong weight. He corrected the weight and the beryllium's atomic weight is 9. And it would be fit in the second group. And its properties practically are similar to the magnesium, calcium, etc. And also, he also helped in the calculation of correct weight of indium and gold also. So this is one of the important point, which means basing on this theory, he corrected the atomic weight of some elements like beryllium, gold, indium, because up to Mendeleev's periodic table, there is no particular arrangement is there. Basing on the atomic weight only, the elements were be arranged. But there is no sufficient calculation is also not available at that time to calculate the atomic weight of the element. Some mistakes also be there. So basing on this theory, he corrected some atomic weights of elements like beryllium, indium and gold. So this is one of the important point. But here in this theory, there is some anomalous series which is also there. What is the anomalous series? Means, for example, here in the periodic table, tellurium is there. The atomic weight of tellurium is 127.6 era. And iodine is 126.9. So here what happened? The tellurium's atomic weight is 127. It is given wrong here. 127.6 and iodine's atomic weight is 127. So basing on their atomic weight, the iodine will be comes first, then after the tellurium will be arranged. But he arranged the tellurium first in the table, placed before the element with less atomic weight and iodine. So the Mendeleev accepted the minor inversions in order to increasing atomic the periodic table. So this is one of the what you call anomalous series, or it is a limitation also. So these are the properties of the Mendeleev's periodic table. And here also some limitations are there. What is the limitation? Means like this anomalous pairs are arranged in this periodic table. This is one limitation. And second limitation also there. In the groups, there are two subgroups are there, A and B. But the elements with dissimilar properties were placed in the same group as subgroup A and subgroup B. Because here in case of first group. For example, lithium, sodium, potassium. So all these are called alkali metals. But these are arranged with copper, gold, silver. So these are called coinage metals, which means these metals are not having similar properties with the alkali metals, but these are arranged in the same group. So this is one of the limitation. And also chlorine is a halogen, but and manganese is, chlorine is a non-metal. See here, manganese is a metal, but this chlorine and manganese both are arranged in the same group. So this is also one of the limitation. So these two are limitations. To overcome these limitations, again one more classification is came forward. So the next class will be continued in the next class.